Hello! This is part 3 of my video series titled Repairs by the Number, Troubles by the Score. In parts 1 and 2 I performed a series of repairs and I highly recommend you to watch those two episodes before this one. The links can be found in the description of this video. Okay, so let's get on with the repair jobs and builds that I want to show you today. In part 1 I mentioned that I had been sleeping on this thing without even a bed frame for over 2 years. I also had only a minimum amount of furniture in the bedroom and in the house as a whole. And boy, don't you even get me started about all them young ladies waiting to have a sleepover at this place. Well, to be honest guys, these conditions were depressing to live under, and that's why I decided to build a bed and a desk from the cheapest wood I could get my hands on. So again, I bought standard 4x6 cm spruce bars. This is basically raw construction wood that no normal person would use to build furniture with. But it's really cheap, and that's why I used it for this job. I cut the pieces to length with my jigsaw and used some sandpaper to smoothen the surfaces and edges wherever I could. After pre-drilling the parts with the drill press, I screwed the spruce parts together to form a support that I then mounted to this heavy plate of teak wood that I had gotten my hands on for free a couple of months before. I used screws and steel angle plates to connect it all together. I know that screwing into the end grain usually doesn't make the best connections, but together with the steel plates, the frame got still quite rugged. To make the spruce parts resemble the color of the tabletop at least to some degree, I applied teak-colored wood stain to the entire frame. I then waited several days for the stain to dry before I applied a layer of transparent protective varnish on the surfaces. And while that varnish was drying, I started to make a bed frame. I bought a couple of pre-planed spruce boards that I screwed to the same kind of standard spruce bars I used earlier in this video. I then made 4 legs from cheaper unplaned spruce boards and used lots of strong screws to connect it all together. Pre-drilling and grinding of surfaces and many other minor things had to be done as well, of course. And after the frame was completed, I again applied teak-colored wood stain all over, waited for a couple of days and applied protective varnish to the surfaces. With the varnish being dried, the bed could be tested. But before the desk would be put in its place, I still had to find a quick fix for this issue. A couple of months ago, one corner of the room had become moist because of a damaged rain gutter, and that had forced me to rip off some of the wallpaper. The rain gutter issue had been fixed some time ago though, and the wall was dry again. So I simply glued a piece of new wallpaper over the free spot. It's not really the same color, but that's not such a big deal, since I put the desk in front of it. And with some stuff put on the desk, this place almost looks like a room that is inhabited by an actual human being. So with the bedroom now being in at least acceptable condition, the rest of the house still needed to be taken care of. But how do you even start to improve the situation if your vacuum cleaner is broken as well? This Miele brand vacuum cleaner had simply stopped working. When turning it on, absolutely nothing happened anymore. And I will now show you what the issue was and how I fixed it. In the meanwhile, I have already taken off a lot of the plastic parts of the enclosure. The teardown basically consisted of unscrewing a bunch of screws. There was really nothing much more to it. What you can see here in white is the vacuum cleaner's universal motor. Behind the motor you can see a small PCB. It simply carries a very rudimentary phase-fired controller based on a triac, as well as a thermal switch that is supposed to cut off the motor from the grid when the temperature inside the enclosure becomes too high. If you want to know how a phase-fired controller works, check out one of my earlier repair videos, which I linked in the video description. Since I cannot see any damage on the PCB, I will focus on the motor itself to find the cause of the malfunction. Before you do that, you should of course measure if the most basic components, namely power cord and switches, are working, which of course I had already done. Under this metal cap we find the impeller of the vacuum cleaner. To take it off, this left-hand screw has to be removed. Other than with most nuts, this one will get loose if you turn it in clockwise direction. With that part removed, a couple of more screws need to be taken out. And upon opening the motor and taking out the rotor, the motor brushes fall out of the enclosure. And here we can see the reason for the malfunction. These brass pins here, which connect the brushes to the wiring of the vacuum cleaner, have broken off. One of them just broke in my hand, while the other one was lying loosely somewhere in the enclosure. No wonder this device did nothing when being turned on. The main current path had been interrupted. To fix this issue, I roughened the brass surfaces and soldered the pins back to the brush holder. My suspicion as to why they broke in the first place is that the pins had to withstand relatively large forces because of the way the brushes are installed inside the motor. Vibrations caused by the motor might have played their part as well. And after having reinstalled the brushes and the motor put back together, let us test the universal motor with 24 volts DC from these two lead-acid batteries. And after having put the vacuum cleaner back together, the cleaning of the house can begin. The next thing that had stopped working was this plastic holder of this navigation system. This thing offers many degrees of freedom, but also has lots of weak spots. These little plastic arms here are broken. One of them actually broke a long time ago, while the second one held up until now. And since driving with a navigation system lying on the floor isn't very safe, I needed to fix this somehow. And I did it the PAI way, which means to replace brittle plastic by rough cut metal. For that I took this piece of aluminium stock and drew the outlines of the broken piece onto it. Then I punch marked it and drilled some holes through the aluminium. Then I cut and filed the piece into shape. I did this 2 times in a row and then I screwed the new arms onto the holder. Once the screws are fastened, it will be very hard to adjust the holder itself by means of the arms, but that is really not necessary at all. My car's windshield always has the same angle. I also always sit on the same spot when driving the car. So why would I even need to have that? So with the aluminium pieces added, I reattached the navigation system to the windshield and now it can be used again. So after this simple fix, I still faced a much larger challenge. Let me show you what I'm talking about. I'm now over at a friend's house where I will repair this old garage door. Opening the door is very hard, and even if it doesn't look like it, it takes enormous effort to open the gate. The reason for that is that the 2 heavy steel springs on the 2 sides of the door are no longer attached to the frame. The purpose of the springs is to counteract the gravitational force that pulls the gate down. When the springs are in place and under tension, the door can easily be opened and safely closed regardless of its weight. But the problem is that the frame has been eaten away by rust. This happened because the roof of the garage once was leaking and a lot of water was flowing over the bottom part of the gate periodically. The roof has long been fixed, but this garage has been nearly useless for a long time. These bent steel sheets are attached to the frame by several weld spots on both the inside and the outside. And I will cut them off and replace them by much stronger parts. I do that with one of my angle grinders and a cut-off wheel. Also, the rusty bottom part of the frame is cut off. This is done on both sides of the door, of course. And the entire bottom part of the frame that once covered the concrete step at the entrance of the garage is completely corroded, and I remove all of the remains as good as I can. And with that being done, I remove some of the paint from the frame with a wire wheel, because new parts will soon be welded on top of them. But before I can do that, I will first prepare a new angle piece that will later cover the concrete step. I don't have a replacement part for the original S-shaped piece that belongs here, but I will use stock angle steel instead. But because I couldn't transport anything longer than 2 meters, I first have to cut off a shorter piece and weld it to a 2-meter section to create a larger part. And I want to reuse these old angle pieces and hook bolts for that. The old steel sheets and nuts will be thrown away though. In order to do that, I wire wheel one of the old angles and cut it loose. These threaded hook bolts are also being freed from paint and rust with the wire wheel. The old nuts are unscrewed. And one of them also needs to be straightened out. For that, the bolt is heated with a gas torch and bent back into shape. And here is something that hasn't happened before on this channel. At least for one tiny step along the way, I do have a helping hand on my side. After the bolt has cooled down, I wire wheel it again. Apply some oil and add 2 brand new nuts. Why do I even reuse the old bolts? Well, I simply couldn't get any replacement parts nearby, so the old ones will have to do the job. And now the side parts can be prepared. 2 pieces of steel are cut to length and the old angle pieces are welded in place. And with that being done, I attach one of the hooks in advance. Now the part is ready to be welded to the frame. It is fastened with a clamp and welded to the frame and the new bottom section. And after that I had to grind off some protruding weld spots, because otherwise the door wouldn't have enough room to properly close. The weld seams on the bottom and on the other side of the frame are much stronger and will do most of the work. This whole thing is of course done on both sides of the entrance. But before installing the springs and testing the mechanism, I first wire wheel some additional rusty spots all around the frame and on the inside of the door. And of course the old springs themselves. Also, a new chain is cut into 2 shorter sections that will be needed to put the springs under tension. And now the springs are linked into the gate and a section of chain is added. The hook bolts are connected to the chain and with the help of the nuts, tension is applied to the springs, both on the left and on the right hand side of the gate. Now it is time to test the mechanism by opening and closing the gate. And everything works just fine. And with the gate being back into basic operation, I apply protective paint to the surfaces of the new steel parts and the other spots that I had previously ground off with a wire wheel. Later I will possibly add a little piece of steel like this on the bottom of the frame. It is needed to lock the door, but since the key for the door hasn't been found yet and the door on this private property hasn't been unlocked for decades, that might not be an issue after all. Therefore I have painted the bottom part as well. In the coming days, some mortar or something similar will be added to the bottom angle steel to make a better fit with the concrete step beneath. Possibly the angle steel will also be bolted to the ground. Okay, so that's it for now guys, but rest assured that more stuff will be coming soon.